Onto the non-calculator section, and this is honestly a free 2 marks. Whenever we're using s equals theta r or r theta to solve for arc length, there's one trick that they can throw at you using this formula, and that is the fact that theta must be in radians for this formula to work. They're almost always going to give it to you in degrees, which they have here, 35 degrees, because that will at least add another step to it that you'll have to convert to radians first to use the formula. So in this case, they've given a student solution and they've just plugged the 35 in for theta. So explain why this solution is incorrect, and this could essentially be the answer that you write. Theta must be in radians for s equals theta r to work. And then don't forget, it does say write the correct solution. So we will need to convert 35 degrees to radians. How do we convert degrees to radians? We need to multiply by pi over 180, because that's the ratio of degrees to radians, pi radians for every 180 degrees. And then this can reduce. If we divide them both by 5, we get 7 pi over 36. So that's our angle in radians. Now we can plug this in to find s, or the arc length. So it's 7 pi over 36 times 6, which is the radius. These can reduce to 1 over 6. So the final answer is 7 pi over 6. I would just leave this as an exact solution. 7 pi over 6 centimeters. Arc length is measured in the same distance, the same units as the radius is. Okay, so every time there's an s equals theta r or an arc length question, they may not give you the formula, but whenever arc length is mentioned, s equals r theta, where theta must be in radians.